I forgot that would probably happen. Okay, so we got the ship. He's gone 24 miles east or west, and 10 miles south. What is his distance and direction from port? So, here's port. So, distance is easy, right? That's the distance. If this is west and this is south, isn't this a right angle right here? So what kind of triangle do we have? A right triangle? So to find that distance, we'll just do the Pythagorean Theorem. So 24 squared plus 10 squared equals x squared. So I can do that on my calculator and come up with, I think that's a Pythagorean triple, actually. It is. That's 26 miles. Okay? Now, what is his direction from port? So his direction now is going to be this angle. That's what we're looking for. Now, if you think about this for a minute, if I went all the way up to the 24 line, all the way to here, that angle would be 270, right? So if I could somehow find this angle, I know the blue one by just doing 270 minus the red one. Okay, so let's look at that triangle. Tell me what we know about this angle right here. I'll use a different letter, I'll call it Y. Tell me what we know about that angle right there. This is a right triangle, so what do I know about it? Alexis?
The 26, the hypotenuse, the 10 is the opposite, and the 24 is the adjacent.
Right. So we got hypotenuse, we have adjacent, we have opposite. So I'm going to say the tangent of y equals 10/24. Is that true? Now I chose tangent because these two numbers were like given in the problem. In this case, I could have used 26 because that's not rounded off. That came out to be an exact number. But usually, that one's rounded off, so I don't want to use it. I want to use the 10 and the 24. Then, how do I type this into my calculator?
10 negative 1.
Yep, second tangent. That's exactly right. So, make sure you're in degrees. And then second tangent. 10 over 24. I got 22.62. That is not the answer to the question though, right? Remember, the answer to the question was the big blue angle. So the big blue angle is going to be 270 minus 22.62. So the answer is 247.38. So his distance from port is 26 miles, and his direction is 247.38. Is he?
Did you do 180 plus that number, or no? To get it, or do you have to do the?
No, that all directions have to be measured from due north. So you need to go all the way around. Okay. Robbie is walking at a pace of 2.5 miles an hour toward the Algebra Scholars Building. All right, so here's the building, and here's Robbie walking along toward the building. At one point, his angle of elevation is 54 degrees. He's walking this way, he's walking, walking, walking. At another point, it's now 62 degrees. And this is 30 minutes of walking. So that's not a distance. They just tell me that's 30 minutes of walking. And we want to know how tall the building is. Okay? Picture makes sense? All right, so here we go. What do I do? Where do I go? What am I gonna do here?
Since he's going 2.5 miles an hour, he's only gone, he has not gone a whole mile yet because he's only been walking for 30 minutes.
You are on the right track, Alexis, till the very end there. He walked, 30 minutes is half an hour, right? If he walked half an hour at 2.5 miles an hour, how far did he walk? What is this distance? 1.25 miles? So he walked 1.25 miles in that 30 minutes. Right? I am going to need to set up a system of equations. So I'm going to call this right here y. And would you agree that the tangent of 62 equals x over y? Would you agree with that? Now, it's not solvable, but it's a true statement, right? And then similarly, if I look at the whole big triangle, the tangent of 54 equals x over y plus 1.25. Is that true? So now what have we got? We've got a system of equations. We have two equations with x's and y's in them. What do we do when we have to solve a system of equations? You substitute or eliminate, right? Whatever seems to work best. In this case, I think we'll substitute. So I'll multiply the y over to here. And I'll multiply the y plus 1.25 over to here. But since this is a quantity, when I multiply it over to here, I'm going to have to distribute. So I'm going to have tan 54y. So y times tan 54 plus 1.25 times tan 54 equal to x. So I have these two equations, this one and that one. What can I do with those two equations? I can set them equal to each other because they're both equal to x, right? So they're equal to each other. So y tan 62 equals y tan 54 plus 1.25 tan 54. So when I looked at my original situation, I wrote two equations. But now, how many equations do I have? One, and there's only one variable in it. That I can solve. That I can solve. So, let's subtract this over. So we have y tan 62 minus y tan 54. In other words, I am putting the y's on the same side of the equation so that I can factor it out. Because ultimately, gang, we want to end up with y equals, don't we? That's what we need. We need y equals. So to get y equals, after I factor this y out, I'll just divide by my parentheses here. So I have 1.25 tan 54 divided by tan 62 minus tan 54. And that is what I'm going to type into my calculator. And I'm going to do that very carefully. 1.25 tan 54. And I usually hit equals at that point, but you don't have to. divided by parentheses tan 62 minus tan 54. Now, I would really appreciate it if you'd all type this in with me, because you've got to remember to put this parentheses in, but let me tell you something else. As soon as you hit tan, like you say, okay, divided by parentheses, tan, this parentheses pops up, right? So you type that 62, then you've got to close that one, minus tan 54, another one pops in, and then you've got your big parentheses. Anyhow, you should end up with 3.41. So you're typing it in right if you got 3.41. If you didn't, you're typing it in right. Now, be careful. That's a ton of work, but we're not done. Because what did we just find? Y. And what was the question? X. So I want you to look at this right here, one of our steps along the way. Didn't we say that x equaled y times the tangent of 62? So y is on my calculator, so I'm just going to say times tan 62. Did you get 6.42? Okay, this is obviously a ridiculous problem, because what's the unit on that? What's the unit on this distance? Yeah, so this building is 6 miles high. That doesn't make any sense, but that's what happens when Mrs. Ford looks at problems. They sometimes don't make sense. Quit watching your phone, your watch, or whatever you got there. Okay? All right. Find the angle of depression of a goose that is 50 feet above the ground. Here's the goose. And needs to land at the edge of a small pond that is 198 feet from the goose. So where does the 198 go? Hypotenuse. Literally, here's the goose, here's the pond. They're 198 feet apart. And our job is to find the angle. The angle of depression is technically right here. It's not in the triangle. It's right here. But isn't that angle the same as this angle because of alternate interior? So therefore, I just put it in the triangle. All right. Need an equation. Sine. It'll be sine x equals 50 over 198. And how do I type that into my calculator? Second sine.
50 divided by 198.
Does everybody understand why it's sine? Second sine, opposite over hypotenuse. 50 divided by 198. That one's easy to type in. Did you get 14.63 degrees? Okay? All right. One more. And we'll do whatever problems you want to do. Find the area of the shaded region and the length of the arc. So it's a two-part problem. We've got this scenario. Okay, we want the area of the shaded region. Okay, so that's that. And we know the radius is 4. So we'll just do the area first, then we'll do the arc. All right. Anybody have an idea how to do the area of the shaded region?
2r5.
What?
2r5.
2r pi? 2 pi r?
Yeah.
Now, 2 pi r is an area. 2 pi r is circumference. And we use that on some problems. But this one is area. What's our formula for the area of the whole circle? pi r squared, which would be 16 pi. Right? The whole circle is 16 pi. So, guys, if I did this, if I said, find the area of the shaded, wouldn't you just take half of that?
Yeah.
Okay, use the same idea, only it's not half. It's what fraction of the circle is shaded there. Not half of it, but
105 over 360.
okay, 105 over 360 would be this piece. So I could find that piece and subtract it from here. Or I could use the same idea, but use this angle, the shaded angle, which would be what? 255 over 360? Did I subtract right?
Yeah.
So this angle right here is 255. And that fraction then is what's shaded. You guys understand? You could do it either way. But if you use 105, you have to subtract that from the 16 pi. All right, so this times 16 pi, it's this fraction of the whole. Now, you're going to answer this exactly, but you can use your calculator to help you with your arithmetic. So if you do 255 times 16 divided by 360, and then do math frac, it'll tell you 34 thirds. So this is 34 thirds pi. So press your math button, and then the first option is frac, and that will reduce that for you and turn it back into a fraction. Or you can just start canceling. You can cancel just like you always do. It'll come down to 34 thirds. This is the exact answer. All right, everybody okay with that? Okay, then the next part, the last question says, find the length of the arc. So this is the arc that you are finding. Now, I'm going to come back to what Reese said a minute ago, because this is not the way we did the problems earlier, but there's always more than one way to do the problem, and Reese has suggested you do something with 2 pi r. Now, 2 pi r, so in this problem, 2 pi r would be 8 pi, is the whole circumference. Would you agree with that? That that's the whole way around? Well, we can use this same idea. We don't want the whole way around. We only want this piece of it. Well, what fraction is that blue piece? 105 over 360? So you can find your arc length doing exactly what you did here, but here you did it with area, and here we're going to do it with circumference. So 105 3/60 times 8 pi. That will give you the arc length, because the entire arc is 8 pi, and you want this fraction of it. So again, I'll let my calculator do the work. I got 7/3. Now you will get 7/3 no matter how you do the problem. The way we did it earlier in the chapter was we found arc length by doing radius times radians. That'll work, but you got to change this into radians first. Okay, and then multiply by the radius, and then you'll get 7 pi over 3 when you reduce it. Now, units. Are there any? Yes. If this is centimeters, then your area unit is square centimeters, and your arc length unit is just regular centimeters. Okay? So we have finished now that sheet, that pretest sheet. You have additional sheets there, and we have 15 minutes or so, 10 to 11 minutes, before we're going to lunch. So let's do some more review. What do we need to review? Did anyone do as I asked and come today with some questions? With specific questions that you want to look at? Alexis?
On page 13, page number 1.
So in the packet, is there a page that says 13 on it?
Yeah, it's right after
Oh, I see, 13. And you want to do which one?
1.
Number 1, change the radians, 28.12 degrees, so we're going to change the radians. And there's no instruction on here about exact or not, but this will be an exact problem, so we're not going to use our calculator except to help us with arithmetic. So 28.12 degrees, changing it into radians. Pi is to 180 as something is to 28.12. That's how I change degrees into radians. I know that pi radians is equivalent to 180 degrees. So how many radians are equivalent to 28.12 degrees? So x equals 28.12 pi over 180. Now again, I'm going to leave my answer exact, but I'm going to do 28.12 divided by 180. Math frac that. Oh, yucky. It's 703 over 4,500 pi. So that would be my exact answer. Okay, so I just typed this fraction into my calculator. It came out a decimal. I get math frac, and it gave me this fraction. Okay? Yes.
If you didn't hit math frac, would the other answer still be wrong?
We don't like to combine, a decimal is a fraction, and we don't like to combine fractions within fractions. We like to simplify. So basically what happened here, Abby, is this became, we multiplied by 100, and then multiplied this one by 100, and then that fraction evidently reduces to this. Okay, who else has something that, you know, it can be, even if you don't have another example of the problem, if you say, well, I didn't quite understand number 6 on the pretest, we can do another one like it. Izzy?
On page 7, the practice quiz for 7.
So I do not understand my numbering system here, but there's a page called 7.
So it's going to be number 3 for y, 2 sine 1/3 x minus pi over 4 minus 1.
Okay, there must be 2 number 7s, because that's not the 7 on that map. There are 2 number 7s. Okay, which problem did you say?
Number 3, and then do you mind if we graph it too?
Yep, we can graph it too. Now, this number is already factored out. Remember, if it's not, that's how you start. So whatever coefficient there is on x, it has to be factored out. This one's already factored out, so it's good to go. But if it's not already, you gotta take care of that. Okay, so let's go ahead and sketch it, and then we can fill in all the other stuff we need to. Okay, so it's a sine curve, and it's positive. So I know that it's going to have this shape. That's a sine shape. But because of this right here, remember, adds and subtracts move you. So if you got an add or subtract in your equation, you've moved somehow. Adding and subtracting in the parentheses moves me sideways. So this sine curve is starting at pi over 2. It's the same shape, it's a regular sine shape, but it's starting at pi over 4. Now, I'm going to take care of this later. I can't handle too much at once. I'm 63 years old, so I got to do it step by step. So I'm going to handle that later. I'm doing this part first. My amplitude is 2, so I'm going to go ahead and mark that on here. And now I need to know my period, because that is the only way I can find my end point. I need to know how far it is between my fingers. The distance between my fingers is the period. Who remembers how to find the period of a sine, Ben?
Would it be pi over 4 divided by 1/3?
It is definitely divided by 1/3, but it's always 2 pi divided by 1/3. Well, 2 pi divided by this number, okay? So the period of a regular sine curve is 2 pi. That gets divided by this number. Okay, it's always 2 pi for a sine and a cosine. All right, so what's 2 pi divided by 1/3? 6 pi, which is 24/4. If I want to think about it in terms of my starting point. My starting point is 1/4. The distance between my fingers is 24/4. So what's this? 25/4. That's exactly right. Your end point is your starting point plus your period, right? So now I know my end point. This point is right in the middle of 1 and 25. Average them. 1 plus 25 divided by 2. 13. This point is right in the middle of 1 and 13. Average them. 1 plus 13 divided by 2.
7.
And 13 and 25 divided by 2. That is a picture of this. So now I have to take this and move it down 1. So all these points that I labeled, I'm going to move down 1. So my final answer is the blue picture, because it is my original down 1. So now this low point actually is down at -3, and my high point is at 1. But that does not change the amplitude. The amplitude of that curve is 2. Because isn't the height still 2? Yeah. So the amplitude is 2. The period, we already figured out, was 6 pi. The phase shift is the horizontal shift, and that was positive pi over 4. The vertical shift was -1. That's the last thing we did. We dropped it down 1. And the frequency is the reciprocal of the period, so the frequency would be 1 over 6 pi. And please make sure when you write that it's 1 over 6 pi. It's not 1/6 pi, it's 1 over 6 pi.
Are we gonna need to know how to do the tangent for the
Yes, we graph tangents.
like for the period? What would tangent?
It's always pi divided by that number. The period of the tangent is pi. Okay? All right, let's do one more problem quickly. Let me just randomly pick one since we don't have a whole lot of time. Let's solve, I'm on that same page, that number 7, and I'm solving the equation 2 sine x plus 1 equals 0. And I'm doing it in radians according to the directions. Those directions mean radians. 2 pi is a radian measure. Would you agree, I'm solving this equation, would you agree that I'm going to subtract 1 and divide by 2?
Yeah.
So we're all good on that part? Now, where Think about the whole thing, this means all the way around. Where in the coordinate plane is the sign a negative number? Now think about that. Sign is negative, where, Colin? Down. And I don't know how he knew that, but how I remember it is sign is y. Sign is y. And y is negative down here. So you're gonna have an answer here and an answer here. In this triangle, both triangles, they're the same. The opposite is -1 and the hypotenuse is 2. You should recognize that triangle. How big is this angle? Across from the 1 is 30. I'm supposed to be doing this in radians, so 30 is a sixth of 180. So it's pi over 6. Now, it's 30, and if you want to do the problem as in the 30 and then change it at the end, that's okay. Now, is pi over 6 an answer to the question? No. The answers to the question have to be over here in quadrant 3. So the blue one and the red one are the actual answers to the problem. So how do we get the blue one? Alexis?
Pi minus pi divided by 6.
Well, actually, the blue one would be pi plus pi over 6, wouldn't it? Because we're going all the way to here, which is pi 180 plus this angle. So in degrees, it would be 180 plus 30, 210. In radians, it's 1 pi plus a sixth of a pi, so 7 pi over 6. And then how about the red one?
2 pi minus
2 pi minus pi over 6. In degrees, it would be 360 minus 30. But it's 2 pi minus a 6, which is what, 11/6? Because that's 12/6 minus 1/6. So those two answers would be the answers to the question, the blue and the red. There's a lot going on there. All right. Let's see, 22. We're back at 22. Everybody's in your seat at 22. Make sure you have gone to the bathroom and taken care of business. We have